This Week in Virology, the podcast about viruses, the kind that make you sick. This Week in Virology, Episode 9, November 21st, 2008. I'm Vincent Racaniello.
And I'm Dick Despommier.
And here we are in New York City, where it is now freezing.
It is.
Temperature is now 0 degrees centigrade.
Yep.
What does it do to mosquitoes, Dick?
It forces them to hide in sewers.
But they will survive the winter, right?
Many of them.
Before there were sewers, where did they hide?
Animal burrows.
Yeah, there's always something, isn't
Nature's sewer.
Yes.
And many of them can winter over, by the way, underneath the permafrost that develops in the soil.
So the mosquitoes will live there, or their eggs?
Their eggs, primarily their eggs. But ever since there's been sewers, there have been mosquitoes that can live up underneath them and take advantage of that. In fact, they can spend the whole winter without feeding. And they can make a brood of eggs without mating.
And they don't move. They just stay.
They just sit there.
It's sort of a hibernation.
That's correct.
And any viruses that are there remain and come back in the spring.
This is exact. Like, for instance, West Nile.
Fabulous. Science is wonderful, isn't it?
I tell you.
Well, today we have an interesting show, but before we get started, I have a question from one of our listeners.
One of our
Chris, many listeners. This is from Chris in Canada, who sent us a multiple choice question. Let's see if we can get the answer, Dick, okay? The surface proteins of flu change over time because, A, the virus likes a change, B, the virus wants to avoid antibodies, C, the virus needs to replicate in birds and humans, D, the virus is trying to outsmart T cells, E, none of the above.
I'm going to pick E. I'm afraid I'm going to have to go with E.
Dick, fabulous. I didn't even tell Dick this question before I came in here. Why is it E?
Why do you think E is? Oh, well, to our many listeners, and I'm sure they're all laughing at this one too, it turns out that viruses don't really have a brain, and even if they did, there wouldn't be a way to behave in a way that has purpose. Nature just doesn't work that way, does it, Vince?
Dick, I'm so pleased I didn't have to prompt you. You're right, viruses don't do anything.
They respond to the environmental changes. So the mutants that are created by the replication cycle are either fit or not as fit for the next environmental change. And that's the answer to how viruses mutate and why they're selected for, I should say. The environment selects for the mutants. The mutant doesn't select the environment.
We all, though, make the mistake of having viruses do things because it's much easier to speak of virology by doing that. And if you think about it, the sentence that you have to construct, to have viruses going through their replicative cycles are often tortuous. So as long as we realize, as long as we recognize, as Chris said, as long as you recognize that you can't do something, it's okay if you do it now and then.
That's called anthropomorphizing.
Exactly. So he had this on a question in a class, he told me, and no one got it right.
No wonder.
I'm going to put it on my virology exam.
Excellent.
Which is December 15th, something like that. Well, Chris also wondered about our statement last time that there aren't any mutations other than genetic mutations. Remember, we were making an issue of genetic mutations. So he said, what about epigenetic mutations?
Ooh.
What do you think, Dick?
Well, I don't think that's the way it works because epigenetics is under the control of proteins usually, and proteins are the products of genes, and genes are the things that mutate, not the proteins.
Yeah.
So I think that's my explanation.
The word epigenetics means other than the nucleic acid, right?
Right.
So,
Now, there can be RNA editing.
Right. But that doesn't change the underlying DNA sequence.
No, that does not.
In the case of organisms with DNA genomes.
That's right.
There is also RNA editing in RNA viruses.
Yes?
Or I should say during replication of RNA viruses.
Really?
But the genetic code, the genome, the RNA does not change. It's only the messenger RNA that changes. Yeah.
So, Vince, let me just ask you this short question then. Where do you think RNA editing was first discovered?
New York Times. I'm sorry.
All the news that's fit to edit?
Trypanosomes?
Correct. Which is protozoan.
Yes, one of your guys.
Exactly, one of our guys. Actually, Ken Stewart, working out in Seattle, was the one that championed the work on the the editing of RNA transcripts.
It also occurs in the genomes of, or I should say during the replication cycles of some RNA viruses like measles virus.
Indeed.
And the result is that a messenger RNA could produce more than one protein because it changes the reading frame.
Right. The other thing it does is it stabilizes the RNA molecule and prevents it from becoming degraded more rapidly.
Is that right?
That's correct.
That I didn't know.
That's one of the effects of
I've learned
RNA
something
editing.
already.
At least that's what I'm told.
Okay. Today, we're going to talk about something that transpired 39 years ago.
Wow.
Around Thanksgiving time, actually.
Indeed.
And let me just tell you, as a little bit of background, I have in front of me a paperback book which was published in 1974. I bought this after I graduated from college. When I left Cornell, I worked for a year in a microbiology lab,
Really?
searching for my future.
I did the same thing, Vince.
And maybe someday we should talk about how we got into microbiology. It's an interesting story.
A good topic.
I bought this book, I read it, and this book made me want to work on viruses.
I'll be darned.
The name of the book is Fever.
Uh-huh.
It's by John G. Fuller. You can't buy it anymore.
Nope.
I looked on Amazon, but I have it. I'm going to scan the cover and put it on our TWiV website.
You have a collector's item.
It is, here, let me read the back, and then we can talk about this.
Sure.
February 1969, that's when the events described in this book occur.
Yep.
Deadly, unidentified virus reported from remote African missionary hospital. 2 American nurses stricken, dead within 10 days. Latest victim airlifted to special isolation ward at New York's Columbia-Presbyterian Hospital. Blood samples rushed to Yale's arbovirus laboratory. All-out search launched to discover an antidote. U.S. public health authorities alarmed. Virus has the potential to decimate whole populations. Avian officials consider cancellation of all jet travel to critical world areas.
Wow. It sounds like a Dustin Hoffman film.
It's in fact all true.
That's right.
This is about Lassa fever.
It is.
Which first was actually ascribed to a virus in 1969, although it had been happening for many years before.
Yep.
As I read, some of this happened here at Columbia. So that's 1969. I hadn't even gone to college yet. Were you here?
I was not here in 1969. I was here in 1970.
But you were close enough that you might recall some of the events that occurred here.
I recall a lot of the events. In fact, I shared an office with the gentleman who we were going to be talking about.
All right, so let's talk. This disease, Lassa fever, which is the subject of this book, is caused by an RNA virus, Lassa virus, which belongs to a family called the Arenaviridae. And this family has an interesting set of viruses. The first member of this family was lymphocytic choriomeningitis virus, which was discovered in 1933. It's a very common virus studied in the laboratory, very easy to work with, has very interesting properties. And then there are a whole bunch of other arenaviruses, and they mainly cause hemorrhagic fevers. Right? Virus infections cause a high fever and bleeding, shock, and often death.
Exactly.
And today we know 23 different arenaviruses, 6 of which are pathogenic for humans.
Wow.
And we talked a few episodes ago about a new form of Lassa recently discovered in Africa, which our colleague Ian Lipkin had been working on as well. So Lassa is apparently the only pathogenic arenavirus in Africa.
That we know of.
That we know of, but I'm sure there are others that we'll find out in the coming years. And these infections typically initially present with nonspecific symptoms, meaning that you really can't tell the organism by the symptoms.
That's
Fever, headache, malaise, muscle aches, joint aches, and then proceeding to total organ involvement and death. In the case of these arenaviruses, 15 to 20% case fatality.
Right.
So that's reasonably high. And about 5,000 deaths a year from Lassa virus. Right. So although we found this virus in 1969, still people are dying.
Oh, yes.
We shouldn't be surprised about that.
I'm not.
So let's go back to 1969. Now, according to this book, some people got sick in Africa. Do you know anything about this?
I actually know the story of this virus pretty well because the gentleman who was responsible for importing the first case of it into the United States in the form of Nurse Pinio, his name was John Frame, Dr. John Frame. And Dr. John Frame worked as an associate for Dr. Harold W. Brown, who was my mentor here while I was a technician in 1962.
Stooley Brown?
I'm afraid that's what they used to call him. That was a derogatory term at that point. Everyone used to denigrate the fact that he was attracted to the parasites that could be diagnosed by looking at common stool. They all did that until, of course, they took their own trips to the tropics and came back with diarrheal disease, and then it was Dr. Harold W. Brown.
Help me, please.
That's exactly right. That's right. So it depends on which shoe the stool is on as to how you view these things. Now, okay, so John Frame went to the University of Chicago for his MD degree, but he was a bit of a rebel, so he actually didn't want to join the AMA when he graduated. What he wanted to do was he wanted to practice tropical medicine. He was raised by his father and mother in Shiraz, Iran. His father was a missionary physician and worked in Iran during the old days when the Shah was still there. And John Frame grew up as a child with international medicine all around him. So when he finished his MD degree, he didn't want to ascend to the throne of an AMA card-carrying member. What he wanted to do was go out and work. And that's just what he did. He never got board certified. And as the result, he had a very difficult time getting appointed to a hospital. And so when he identified himself to Harold W. Brown, who had a similar mindset, but who was board certified, and who was a major player in tropical disease research, he took him on as a colleague at Columbia University. And John Frame used to help Harold Brown teach the tropical medicine course to the medical students here. It was called Parasitic Diseases, and I now teach that course. So that's.
And I think you were just teaching.
I was just teaching about malaria today. So the intellectual knowledge inheritance line goes directly back to Harold W. Brown here at Columbia. So here's Dr. Brown sitting down with John Frame, deciding what John Frame is going to do for research.
This is what year?
This was in 1968.
Okay.
And John said, I can get associated with the United Missions office, which is operating out of Riverside Church on 125th Street. And if I do that, then I would be the U.S.-based physician for about 5,000 missionaries. And you could look at them as sentinel people that would go out to these very remote places for purposes of trying to convert people to their own religious bent, let's just put it this way. Something that I'm ambivalent about. I must tell you that I'm sort of not in favor of that sort of activity, but nonetheless, when it comes to their medicine, I certainly don't want anybody to suffer. So John Frame said, I will be the U.S. physician to whom all of these people will report after they come back from their missions. And I will give them a general checkup, and now we can identify what the rate of infection is for various tropical diseases. And Harold Brown thought that was a marvelous thing for him to do, so he did it. And in 1969, the very next year, John Frame got an emergency telephone call from Lassa, Nigeria, which is where this organism gets its name from. And she said, Dr. Frame, I think there's something unusual going on here in this village. People are dying from a strange disease that we've never seen before. And I must tell you that everybody here is afraid for their life. And John Frame thought this was rather dramatic, and he said, please keep us informed on a weekly basis. And Nurse Pinio said, of course we will. The next day, she called him again. The second day, this was not a week later, this was a day later, and she said, one of our physicians has taken ill. Now, there aren't that many physicians to go around in terms of tropical diseases. Even then, that's certainly true now, too. And he said, well, what do you think will happen? And she said, he's apparently very sick, and if he's got the same thing that these other people have, I'm afraid that he's going to die. And sure enough, in 3 more days, that physician died, to which there was another phone call. Nurse Pinio said, Dr. Frame, I hate to say this, but I'm not feeling very well. Dr. Frame said, book a flight back to New York now. get on an airplane, do not pass go, do not collect $200. Come directly to Columbia-Presbyterian Hospital. I will meet you at the airport. I will personally escort you into the hospital. We will admit you into the intensive care unit, and we will find out what's wrong. We will help you in every way we can. Now, because John Frame didn't have admitting privileges at Presbyterian Hospital because he was not board certified, he had to get Dr. Harold Brown to help him. And so Dr. Brown did, of course, help him, and in flies Nurse Pinio. Nurse Pinio is admitted to the intensive care unit. She is given supportive therapy only because they didn't even know what she had.
I had no idea that she might even have an infectious disease.
That's correct.
But from her description, that's right. They brought her in without thinking about that.
Exactly right. And remember, she was on an airplane the whole time, so she could have exposed the entire airplane's worth of passengers to this infection, as it turns out.
Yeah. Yes.
So this could have started an epidemic, basically, in the United States,
right,
of Lassa fever. As it turns out, that's what she had. As her condition worsened, they began to draw blood and send it off to various places. And one of the premier places to send blood for unknown viral agents was the virus laboratory at Yale.
YABA.
That's right.
YABU. Yale Arbovirus Research Unit or something like that?
Yes, that's right. That's right. YABU. It used to be situated at Rockefeller University, and before that, Rockefeller Institute.
And who was the head?
Rivers was the head of that then.
At Rockefeller?
That's right.
And when it moved to Yale?
Shope.
The famous Shope papillomavirus.
No, that was his son. His son became in charge of the laboratory at Yale.
What did Shope Dad do?
Shope Dad's unfortunately died. He died of pancreatic cancer, along with Peyton Rouse 1 year later. They both shared the same lab. I know because I was a postdoc there for 3 years. So
at Yale?
No, at Rockefeller.
Rockefeller.
Yeah. So Shope Sr. was at Rockefeller, and he studied flu virus, basically. He studied swine flu.
Okay.
Right. And he also was the co-discoverer of the Shope papillomavirus.
Okay.
All right. So now you've got serum, but the laboratory, because of a change in emphasis, perhaps, academic things, the way they are, the virus laboratory was asked to move. So they got an offer from Yale, and they moved up to Yale, and that's where the head of that laboratory was now Jordi Casals. Jordi Casals was a very, very famous virologist, and just recently passed away, by the way, and I think this year, as a matter of fact. Jordi Casals receives serum from Nurse Pinio. Now it's around Thanksgiving. In fact, right at this time of the year, this is a perfect time to tell this story, because what they do when they get an unknown sample, what would virologists do with a blood sample, Vince?
I receive a blood sample from someone who's suspected to have a virus infection.
Of unknown origins. What do you do with it?
Yeah. Well, I drink it.
And then what would you do?
Well, I would
write out your will, I presume.
Centrifuge out the blood cells, and I'd take a little bit of the supernatant and put it on some cells in the laboratory. And, or maybe if I had an electron microscope, I would look at it to see if there was something there.
But let's say the viral titers
Which
are so
year
low.
are we talking about, today or in 1969?
1969.
Look for antibodies against some known viruses?
Yep. You didn't find any cross-reactions, by the way.
No cross-reactivities back then? They looked.
That's right. What about animal studies? Would you do anything
with
animals?
Stick it into some mice.
Right. So who would actually do that study?
Me.
You think you would do that study? Vince Racaniello or Vince Racaniello's technician?
Well, traditionally the tech would, but since I'm a hands-on guy, but probably Jordi, I don't know which way you'd like to say it.
Jordi.
Yeah, gave it to his technician.
Jordi gave it to his technician.
Right.
That's what he did.
What was her name?
His. Don't remember. Actually, I didn't know that group. It's in the book, though. I'm sure it's in the book.
You talk, I'll find it.
Okay, fine. So the technician is given the job of injecting a serum sample from Nurse Pinio into mice. Let's talk about the routes of infection. How many different routes of infection do you think there are for virus infections, Vince?
In humans?
In anybody.
There is, the main route is respiratory.
Okay.
Then there's alimentary tract.
Okay.
Urogenital tract.
All right.
Skin.
Yep.
Eye.
Yep.
That's basically it.
What about a fifth one? How do we catch rabies?
Yeah, skin is included. Scratches, needles, vector bites, animal bites.
Okay, okay. And any mosquito vectors too, right?
Right.
Okay,
ticks,
so
mosquitoes.
You can inject it. So the technician is faced with choices here. So he injected it intravenously into some mice. He injected it intraperitoneally into some mice. And he injected it intrathecally into some mice.
Juan Roman.
Intrathecal, it means directly into the brain.
Yes.
All right, now...
His name is Juan Roman.
I'm sorry.
Hey, listen to this. Thanksgiving was coming to Connecticut. It's in the story of Lassa. Yordi closed up shop, went down the hall. On the way, he said hello to Juan Roman, a young lab technician who was working on research. Yeah, so that was the technician's guy name.
So Juan Ramon, his family lived in Pennsylvania. So Juan Ramon, after finishing up his work of injecting intravenously, intraperitoneally, and intrathecally, went home for Thanksgiving vacation. Unbeknownst to everybody except Juan accidentally stuck himself with a needle. When he was injecting the mice intrathecally, the needle slipped.
It happens.
It does happen, and he injected himself in the finger. So what do you think happened next?
Went home for Thanksgiving, started feeling sick.
And then?
Got sicker.
And then?
Did he come back to work? He never made it back to work. Died.
He died.
Before he went back to Yale, he died.
He died. Jordi Casals, in the meantime, came back to lab, unbeknownst to Juan Ramon, and began working on this virus too. And he inoculated it into cell cultures. And unfortunately, also became exposed.
Jordi did.
He did. So the head of the laboratory now has what you would be afraid of calling a brand new disease, but in fact, that's exactly what he had. So we now have two pictures of this outbreak. We have the African picture and we have the American picture. In the American theater...
So several people in Africa had already died by this point,
Many people had died. Many native people.
What happened to the woman who came...
Nurse Pinio. I'm going to get to her.
You're going to get to her. Okay.
She's in the intensive care unit at Columbia-Presbyterian Hospital. John Frame is her physician. The intensive care unit managed this patient with supportive therapy only. We didn't have interferon in those days. We didn't have any of these antiviral agents in those days. And besides, they didn't know it was a virus anyway. That's why they sent the sample up to Yale. They did a lot of other things, too. They tried to culture it in bacterial cultures, fungal cultures. Nothing else came back positive. But in the meantime, the story came back to the Columbia-Presbyterian Hospital that Dr. Casals was sick and one of his technicians had died, and probably as a result of exposure to something that Nurse Pinio's serum contained. A miracle happens at this point. Nurse Pinio begins to get better. In fact, Nurse Pinio is beyond the crisis. I noticed when you read the liner notes on the back of the cover, it said that this virus was going to decimate the population. I want to pause there for a moment. Do you know what the word... Vince almost pushed the pause button on the recorder. No, I want to ask you a question. What do you think the term decimate means?
Kills everyone. Actually, no. Kills many people.
And there's an exact number, by the way, for this one.
Decimate?
Yeah.
10%?
1 out of 10.
That would be 10%, right?
That would be 10%. And you know where it comes from?
No, I don't.
It comes from the Roman legions back in the days of the Caesars, when a band of Roman soldiers failed on the battlefront. They were punished. They were decimated.
1 out of 10 was executed.
This is
fascinating.
Exactly correct. And it was done by the general who came along and chopped the head of the victim off in front of the other people. So
the use here is incorrect, right?
I think it's a little inexact at this point.
Maybe today the word doesn't mean what it used to mean, and it now means a lot. Right?
I know that. It meant something bad was going to happen to the population.
Yeah.
But it was actually the mortality rate for this virus exceeded 10%. But Nurse Pinio's data indicated it was as high as 80%. Because of the people that she saw sick, 80% of those people died. When this virus was brought back to this country and sent up to Yale, one person was already dead, another person was deathly ill, and Nurse Pinio was, well, what was Nurse Pinio? Was she going to die? And in fact, it turned out that she was not going to die. In fact, she lived. So, in an act of desperation, Vince, what would you have done to save Jordi Casals' life?
Knowing that we had now, let's fill in one thing. Where did Jordi Casals live?
He lived in Yale. New Haven. No, he didn't. You know where he lived. Really? He lived right here?
He lived in Fort Washington.
And commuted?
Washington Heights, excuse me. He commuted to Yale.
I didn't know that.
Yes. So
I was not aware of that part of the story.
And that's why, as we'll see, he was treated here, correct?
I don't know the details.
Well, maybe he was treated. I think he was treated here, and Harold New was his physician.
Oh, that's wonderful.
But we're jumping ahead of. I'm sorry. I'm jumping ahead of myself.
But it's okay.
You asked me what would I do.
If you were the doctor in charge of Nurse Pinio.
Let's say I'm taking care of her, and then Jordi Casal is brought in with possibly the same illness because he was infected by something from Nurse Pinio, and she recovered. I would say, let's take her serum and give it to Jordi.
Perfect.
Jordi.
Or however he pronounced his name. Jordi, I believe it was Jordi. Has that ever been done before?
Absolutely.
Really?
Absolutely.
Can we talk about something else that works for?
Oh, it works for many virus infections. It works for influenza, for example. You give pooled human globulin, which have antibodies to the virus, and you can treat infections when you don't have anything else.
What's the most common one we use that for now? Hepatitis.
Which hepatitis?
I believe it's viral hepatitis, not the fecal contaminated, but the hemorrhagic contaminated.
Well, we have hepatitis A.
Oh,
B,
well, we're up to G
C,
now, or
D.
That's right.
E.
I think it was hepatitis A or B. I believe it was one of those two.
Maybe, possibly B. Yeah, I think it was B.
I know for a fact that there's a listener out there cringing at this very moment.
I'm sorry, listener.
Saying that, I know the answer. I know the answer.
Well, send us an email.
Send us the email and help us educate the public with regards to viruses.
So it was done before. That's what I would.
All right. So pooled.
Whose idea was that? Was that Frame's idea?
It was actually. It was. That was a risky thing to do because this person might have still been viremic.
My God, you're absolutely right. Extremely risky.
So they took her serum at the point where they were sure she was going to recover, and they gave it to Jordi Casal.
So it is risky, but why did they do it anyway?
They were desperate.
Why else?
Because it was the only thing to do. There was no other choice.
Even if she had virus, why was it okay to do it?
Because he's already sick. You might as well try something. It's not going to hurt him anymore.
Okay. But she's got antibodies there.
Oh, no. What was the active? Yeah, sure.
So if he gets infected, of course. Then maybe her antibodies will protect him anyway, right?
That's right. Okay. So these were neutralizing antibodies that Nurse Pinio was presumably making against the infection. Thank God it turned out to be a viral infection and not something else. And she was able to essentially save Jordi Casal's life.
Now, Dick, what happens if it turned out that recovery from this infection required cells, immune cells, and not antibodies?
Well,
then they would have been out of luck.
Jordi would have died.
But he lived, right?
He did live.
So the serum saved him.
So what do you think the outcome from that experience was in terms of A, public health, B, virus research, and C, an awareness of the unknown?
Oh, this is really good. Don't you think this is probably the first? First of all, where did this virus? I think those are great. Let's answer them. Where did the virus come from in Africa?
Right. It came from not people. This is a zoonosis. This is carried by
from a zoo?
No. It could have come from a zoo, but it did not come from a zoo. It came from a zoo. It came from a multi-mammate rat.
Mastomus natalensis.
That's Mastomus. Okay. That's right. And why? Remember, our very first edition of This Week in Virology started to discuss ecological factors which favor the outbreak of a disease in terms of viral diseases. And this disease has a huge connection to the environment because multi-mammate rats carry this infection with them, and it doesn't kill them. It's an infection.
Persistent infection.
It's very much like the hantaviruses in mice, and they both transmit it through urine and droppings. Now, multi-mammate rats are very shy animals, and they will not go into houses.
Mice or rats?
Rats. They're rats. Multi-mammate rats.
Okay.
These are rats. They're a little bit bigger than the largest mouse.
Like the one that bit you when you were a kid.
Like the one that bit me when I was a kid.
In New Orleans.
That's right. Now, these rats have to have a good reason for going into your house in order to take the chance. Mm-hmm. Why is that? Because people are smart enough to keep cats around and dogs. And they do that to keep out the snakes.
In Africa.
Yeah. But they also keep out the rats. What would drive a rat into a house, Vince?
Food.
There you go. Now, why do you think the rats were looking for food in the houses rather than where they normally find them in the fields?
Maybe there wasn't much outside and they were storing a lot inside.
It was a drought year.
Mm-hmm.
And, in fact, the crop had just basically failed. And there were lots of rats that were very hungry. And because the grain can be stored inside of these houses, the rats went into the houses looking for the grain. By the way, that was exactly the same reason that we had an outbreak in the Four Corners from hantavirus.
Right, exactly.
Okay, so there are some parallels here that we can draw on to show the connection between the environment and disease outbreak. So Lassa fever was the very first, you might say it was the poster child virus for the new emerging infections.
Exactly. That's just what I wanted to say. I wanted to ask you if you thought this was really the beginning of emerging infections, awareness of emerging infections, because obviously it had been happening already. But
that's right.
This was the first time we realized it could come from animals.
Exactly right. So it taught us several things about viral infections. One is that if you don't know what it is and you have someone who's already had it, you can cure the person who has it by taking serum from the person who has had it.
Mm-hmm.
And hopefully you will interrupt the life cycle. And in most cases, it's actually borne fruit. This has actually worked out very well. Number two is it taught us to be careful with bodily fluids.
Or transporting people who are sick.
And number three, of course, is transporting people.
So the bodily fluids concern, now we would never do this at Georgie's lab at Yale. It would be sent to a BSL-4 facility, right?
That's right.
High containment. And these facilities, of course, weren't in existence in 1969.
We're up to number 4, but there wasn't even number 1 in 1969.
There were no classifications,
There was none. This actually jump-started that logic also. And so there were 2 biological research laboratories of note in 1969. One was in Frederick, Maryland, and this was associated with the Army. And we used to do biological warfare in this country, believe it or not. And they used to have these very, very secure areas which they set aside for that kind of research. The moment they heard about this virus, they started to work on it. And the excuse they used, of course, was like the Iranians using we're developing new nuclear power supplies, that's why we're trying to concentrate all this U-238 when they already have as much oil as you can possibly use. The Army said in their infinite wisdom that we were trying to make vaccines against these infections for the Army. But in reality, I think they were really doing biological warfare research. So John Frame was hired by the Army to go to Africa every year after that to find patients that had recovered from Lassa fever, and he collected their serum, and he brought it back, and he gave it to the Army so that they could stockpile immune serum in case one of the investigators stabbed themselves and got sick.
So in Africa, the people were infected by these rats.
That's right. Or by the urine of the rats.
Urine, saliva, droppings. Something.
Correct.
Then the big mistake was to bring the one person here.
In a way, that was a mistake. Thank God it worked out.
So the lab technician stuck himself with a needle. Do we know how Georgie became infected?
We assume he was trying to do cell culture work, and some fluid contaminated his local environment.
So there was not much person-to-person transmission, right? Why not?
No, that's right. Well, there weren't many sick people. I mean, in this country, when someone gets sick, really sick, they get put into isolation.
So you can assume that these people are coughing and sneezing. They're probably excreting virus, and it could have been picked up, but the numbers were just not there.
And their relatives are visiting them. They're hugging them. They're doing all kinds of things.
It may not be having just come out of a rat. It may not have been very adapted to transmission among humans. Right?
Possible.
But you can imagine that if it's given the opportunity to pass among humans, it would acquire that ability.
That's
Although
right.
I think in Africa it is still a zoonosis.
It is.
Right?
Of course it is. But the hospital in Lassa became the site for infection. So the physicians caught it. The nurses caught it.
Right.
The visitors to the patients caught it.
In fact, in the very beginning of this book, it starts with Laura Wine, who was one of these missionary nurses. She gets up Sunday, January 19th, 1969, got up and realized that the pain in her back was worse. But she got up anyway and went to the hospital and took care of patients. And she was ill for days, kept going to work.
She could have infected lots of people.
Exactly.
Times.
Yeah,
right.
So we learned an awful lot.
We did.
And in a way, it's a shame Steve Morse couldn't join us because he, of course, then became the mantra of emerging infections. Did he coin the term?
I'm not sure he did or not. I think I'll try to remember the
I would like to know that. I've always wondered who coined it.
Emerging infections.
But nowadays, that is all we talk about because we know this to be true, that viruses come from animals, and they do so more frequently because we travel a lot. We're in more contact with animals.
We go to places where we shouldn't be.
It's very interesting that you could remember all the names of that incident. Very good, Dick.
John Frame, every year after that, gave a lecture on this to the School of Public Health students.
Oh, that must have been fabulous.
It was absolutely wonderful.
The days before podcasting, we couldn't record it.
That's right.
Maybe in some archive something is recorded.
I don't know. They made a docudrama out of it, though, in Britain. There's a movie on this.
Really?
Yeah.
So the title of this book is Fever,
right?
And on the front cover it says a true medical detective thriller with all the drama of the Andromeda strain.
Exactly.
Actually, this is better than the Andromeda strain because it was real.
The Andromeda strain was based on this book.
Well, it came out before this.
Yeah. What, the Andromeda strain came out before that?
Yeah,
really?
Apparently. Because in the beginning here of the book, they have a quote from the Andromeda strain.
Oh, all right.
Michael Crichton, who just died.
Who just passed away.
Can I read this quote? It's interesting.
You may.
But things are now under control, Stone said. We have the organism and can continue to study it. We understand what's happening now in terms of mutations. That's the important thing, that we understand. But they probably didn't understand, did they?
Right.
So anyway, this book got me into viruses. That was 1974-5. I had just come out of college, and I spent a year working in a lab and then ended up in a virus lab. And I still have this book. It's amazing.
It is amazing.
And
Keep it, Vince.
I'm glad
it's worth a lot of money.
Well, it's not the money. It was $1.75 back then. It's not the money. It's just the memories. This is one paperback I will always keep. And as I said, I'll put a scan of the cover up so people can look at it.
Great.
It's a great story. Anything else about Jordi Casal's Frame? When did Frame stay here his whole
He did. He actually stayed here his entire career.
Oh, so you interacted with him at some level then?
Absolutely. He used to assist us in the parasitic disease course, and he also gave a lecture in the updates on parasites. We had a similar, it wasn't This Week in Virology, it was more or less updates in parasitic disease course as a refresher course for physicians every summer. And there was a well-attended course, and John used to give a lecture on that as well.
Oh, that must have been great. No, that's really these kinds of stories are very interesting, but we shouldn't lose them. So now we have part of it archived in TWiV. It will exist forever as in a digital form. Exactly. Okay. Before we wrap it up, I want to just mention a few other things. A correction. I don't know what episode it was. You asked me why we hadn't combined the inactivated polio vaccine with some others. And I said it hadn't happened. I was wrong.
It had happened.
Yeah, there's actually a licensed vaccine in the U.S.
I like that.
Which is called PDRX. Got it? PEDIARIX. It's a 5-component vaccine which would be pentavalent. It's licensed in 2002 in the U.S. It has inactivated polio vaccine.
Right.
Diphtheria, tetanus, acellular pertussis, and hepatitis B vaccine.
Excellent.
Wow, 5 components, 2 viruses and 3 bacterial components.
Wow.
So it does exist. My apologies. No one caught us. I caught myself. You know why I figured this out? Today I'm lecturing on vaccines, and I wanted to see the components of various vaccines, and I caught this. So that's corrected. Science Podcast of the Week.
Tell us.
So we had a reader actually write in, Chris, and he listed all his favorite science podcasts because we asked last time for people to do that, and we were on the list.
Really?
And that's nice.
That's great.
And I listened to all of them.
He listed all 4, including us?
Yeah, he had about 6 or 7. If you look at TWiV.tv, the comments section has his email, and you can see the ones he listed.
Very nice.
And the one I liked a lot is a podcast called The Naked Scientists. And it's by a bunch of people in the UK. It's well produced. It was founded by a fellow named Chris Smith, who is a lecturer in virology at Cambridge University. Actually, so Stephen sent me the list of podcasts, and Chris Smith founded The Naked Scientists.
Right.
And so he's a virologist. He does this podcast. It's a wide-ranging science podcast. They do everything. A couple of people involved. It's well-produced. It sounds good. They have nice music, sort of like our podcast, right? And I liked it. But it's nice to know. It's nice to learn about all science, not just microbiology.
Absolutely.
And that's our pick of the week. We'll put a link in the show notes. So thanks, Stephen, for sending in your list. I'll listen to some more and see if we can come up with some future picks. I haven't found any on parasites. I'm looking.
Well, maybe we should start one on that.
This month in parasitology.
This month.
TMIP. TMIP. It's kind of bad, isn't it? Oh, well. Well, we can't use This Week in Parasitology, TWiP, because there's already a TWiP podcast, This Week in Photography. Are you a photographer?
I am.
You should listen to TWiP. It's very good.
I'd rather look at TWiP than listen to it.
I understand.
I mean, as a photographer, you should look at
is a visual
something,
medium,
right?
yes.
It
Yes.
is.
Well, that should do it for today. Your office is cold today.
Thanks, Vince. I would have turned the heat on, but it would have made some background noise, and it would have interrupted our broadcast.
Thanks for being with us, Dick. Well, you're with us every week. Why am I thanking you?
What do you mean us? We are us.
We are us, yes.
We want to wish everybody out there a happy Thanksgiving.
Oh, yes, happy Thanksgiving. Next week, we will not broadcast.
We're going to skip a week.
We're skipping a week for various reasons. We'll be back the week of December 1st, so look for us. In the meantime, enjoy Thanksgiving. You've been listening to This Week in Virology, the podcast about all things viruses. Thanks for listening. So long.
So long.